I was trained as an artist, as a painter, but the longer that I did painting and sculpture and then environmental projects outdoors, I began to notice wildlife and the fact that they no longer had any place as urbanization took over their territory, their food, their habitat. So that's always been one of the issues I cared about. Something else that I think is really important is that if we're going to displace all of these animals, we really need to consider urban infrastructure in a different way, in a very multi-purpose way. And so one of my missions as a designer is to include plants and animals living in ecological communities as a major component of even very large, costly projects. When I first did the project in Dallas, basically I was commissioned to do a conventional sculpture, but I realized that we could create a large body of water, we could use plants to clean the water, we could provide people access via the paths, and also make this part of Dallas's flood control system. And so today, more than 25 years later, Fair Park Lagoon is a municipal flood basin. The water rises and falls depending on how much rain there is. And the paths are reconfigured because of the topography of the sculpture, so that the paths may be flooded and become stepping stones after a heavy rain. And it's filled with ecological niches. So the people that visit Fair Park have actually begun to become very close to nature because they begin to know where each type of turtle lives, where the birds nest, where they're likely to see certain kinds of fish spawning. And this is very important to me because I think the technological future that we are heading into tends to not give us much contact with nature. And so I think it's important for children especially to be able to come in contact with these plants and animals as a matter of their daily course. So Endangered Garden in San Francisco is actually a transport storage sewer. But my idea as co-designer of the sewer was that this could become endangered species habitat and bring people into contact with the life of the bay. And so the first thing I did was bury the entire sewer and use the roof as a trail system, which is now part of the Bay Circuit Trail. And so people can actually access the bay from this roof of the sewer. And what they find there is intertidal life, and they can actually walk out onto the mud flats, they can walk through restored marshes, they can come back up onto the bay walk and go out into a butterfly meadow. And the snake of the head is actually very important because that creates a windbreak for butterflies. This is a very, very windy site. The Alamani Gap is right there where wind funnels in from the Pacific Ocean, and then counter winds come in off San Francisco Bay. And so basically what that head of the snake does is curve around the meadow and create a place where butterflies can fly. And then of course the entire substrate is planted with nectar and food plants for the larvae of the butterflies. And this is very important because there are so many endangered species in the San Francisco Bay region because of the growth of the city. It's literally pushed all of these plants and animals off the peninsula. And so here's an example of a major piece of municipal infrastructure, a sewer, that's actually a trail. It's actually a park. It's part of California State Parks, Candlestick Point State Recreation Area. It provides access to nature in the bay, and it basically educates people about what's going on in this area. When I was asked to work on Petaluma, again, the key to me was to process sewage using wetlands plants. And I was actually on the value engineering team and pushed for the idea of not having a mechanical facility. One of the things we're doing here is we're saving energy. We're processing sewage in a very cost-effective way because it's very low-tech. Basically, the sewage settles out in oxidation ponds, then it flows through treatment wetlands, which filter out the detritus, and it settles further. And then the water is carried through polishing wetlands, where again you'll notice that there are green and blue segments of filtration. And of course in the green segments, those are the plants that are filtering, and the microbes that live on the roots of the plants are eating the detritus. And then when the water hits open water, which are the deeper sections, there are fish in there. And you also have algae, which help oxygenate the water, and sunlight. And so just through this process, the water becomes cleaned, it's pumped up to UV disinfection, and at the end of the process it goes into recycled water reservoirs, and then the water is sent out to be used in agriculture. So this is a deeply functional project, but it also has the whimsical visage of the little salt marsh harvest mouse, which is a local endangered species. We've recreated pickleweed habitat for the mouse, and it's also a public park with more than 3 miles of trails and totally accessible to the public. We now have 8 endangered and threatened species that have moved into the park. And so one of the species that you'll see are clapper rails, which the state of California has tried desperately to preserve and reintroduce, and they've just moved into our site. So this is an example of a very multifunctional piece of infrastructure that also serves humans and wildlife, and at the same time performs services that we